Welcome to today's Developer Skill Sprint. My name is Robert Love and I've been a long-time developer in the Delphi community. You can find me on Twitter using the handle @DelphiDev, and today I will be covering unit testing with DUnitX. This skill sprint works with, or DUnitX specifically works with, Windows and OS X using either RAD Studio or app method and using either the Object Pascal or C++ languages. If you'd like to find more information about these things, what's involved in each of those, there's the DocWikis here that you can use. So what are we going to be covered in this session? This is what is DUnitX. I suspect there are some of you that are not familiar with it, and some of you have loosely heard about it, and so we'll cover a little bit about that, and then we'll actually show how it's used, and we'll go into things about the project structure, how attributes work with it, and the assert class that it has. DUnitX is an open source testing framework that takes ideas from DUnit, NUnit, and other testing frameworks. It was designed to work with Delphi 2010 or later, and makes use of language and RTL features that are not available in older versions of Delphi. In XE8 and RAD Studio and the April 2015 app method, they also have included DUnitX in the box, and so it's now shipping, and those versions are also the only versions that currently support C++. It also has an active community on Google+, which I have here with the URL. tinyurl.com/DUnitX will get you there, instead of the very long URL that normally are with the Google+ communities. DUnitX features contain the ability to have any class can contain a test. So regardless of what it descends from, you can build test methods. And you can do that by just using attributes on those test methods. And so it's attribute-based testing by just adding attributes to a given class. It will work. And then another option is to place your tests in the published section of a given class. That works for both C++ and Object Pascal. And attributes are only supported through Object Pascal. DUnitX has an extensive assert class, which we'll cover today, and we'll have most of the framework is documented using XML documentation. So if you ever need any help on anything, the odds are go look at the code. There's going to be docs on it, and tons of them. The console-based test runner by default. It also works with Test Insight, which is an IDE plugin that is incredibly nice, and it's there. You can see bitbucket.org. There's the URL for it, and although we won't be covering Test Insight today, feel free to use it and look at it. It's well worth your time. XML-based logging that's compatible with NUnit. So this allows you to use like continuous integration servers, such as Continuous CI, and you'll be able to use those in your build process so that your tests are run all the time, and they're imported successfully into those tools, so you can see what passes and fails and that from your build servers. It also has limited backwards support for some compatibility with DUnit if you choose to move your tests forward from DUnit to DUnitX. I should mention that DUnit also supports the Test Insight plugin that I mentioned earlier. So if you're still using DUnit in your current unit tests, you can also still use the Test Insight plugin as well. So let's move on to a quick demonstration. Okay, for the demo today I've built 3 projects. One is a FireMonkey project, the other one's a VCL, and the third is our test. Both the VCL and the FireMonkey project are going to use the same class that we're going to build tests for. These applications are very simple and provide a way to enter in two numbers and provide a way to add, subtract, multiply, and divide. I know, not very complex, but it allows us to spend less time thinking about the code and more time focusing on the test for the demo. So although I've built two user interfaces, the first point I want to make is DUnitX is not for testing the UI. It's for testing the underlying code. So the only unit we'll be testing today is the calculator unit. So if I go in, it's shared, it's in a common directory here. Notice this calculator unit has four methods. They're all class functions. And to build our first test for the code, we need to use the DUnitX wizard. This can be found under the File, New, Other menu. So if we do File, New, Other, you'll find that there are four DUnit experts. There are two for C++ and two for Delphi. And I'm going to start off right now with a DUnitX project for Delphi. With this, it gives us, the first checkbox here allows us to create a new project group or just add it to the existing project group. So in this case, we're going to just add it to the existing group. The next option allows us to create an empty unit test. You have the options to create setup and teardown methods, and you have the option to create some sample methods, what we'll do just so that we can show you some examples. Then you need to specify the class name of the fixture you'll be creating. The fixture is the class where your tests will reside. A DUnit project can have as many fixtures as desired, but it does need to have at least one. So let's start off by selecting these and then saying tcalc test. Now I have created an empty unit, and you'll see the first unit is the DUnitX test framework. This contains the majority of everything you'll need for your unit tests. It does keep it simple and keeps the uses clause down. The next thing you'll notice is the test fixture attribute. This must be applied to all the classes that you intend to have tests residing within. The next one is we have setup and teardown methods. These are just two empty methods where you might create objects or free them for every test that's executed. So since I have two tests, one called test 1 and 2, setup will be executed twice. Once for test 1 and then turn around and be executed once again for test 2. The class will be recreated for every test. So that's just something to be aware of. The next thing is I have a test 1, and notice if it has no parameters, all I have to do is call test. And the next one that we have here has two parameters, and with that I have a test case and a test case, and it just basically allows me to pass the parameters with a comma separated list. If you have commas in the data, there's a third parameter that allows you to change that separator. So with all testing frameworks, you need a way to know whether or not your test was successful or not. And so there's the assert class that we're going to start with. So the assert class has many, many overloads, in fact over 70 of them. And so we're going to have one that just says pass here, and it says this passes. And notice how the string is optional. And we can come here and change this to fail and just say this fails. And we got a spell fail right. Alright. If I run this, it's going to come up with a console window. The console window is going to show me that I have one test passed and two that failed. And you'll notice that it lists the whole unit, the class, the method name, and then the name that you gave the set of data that you were after. And I didn't even spell fails right, and then this fails part. But ultimately this gives us an idea of what's going on here. So why don't I close this little example and go open the other one that I've built. And so we're just gonna, well actually I'm just gonna switch. So we'll just go to the test project here, and I'm gonna go into the test calculator unit. We're gonna show a few different tests. So for the add method, I had a value 1, a value 2, and an expected value. Alright? We pass in 1 and 1 and get back 2, or 0, 0 and get back 0. Negative 1 plus 1, 0. Negative 1 and negative 1 and negative 2. Why did I do this? Well, when you're dealing with unit tests, you want to test different boundary conditions, and one of those with arithmetic is, do we handle both sides of 0, and does everything happen correctly with positive and negative? If we go look at the actual test, I've declared a variable called test result. Test result is then used with the tCalculator class that we had, which we call add, where we pass in the value 1 and value 2. And then we call assert are you equal, and we pass in the expected value and the test result. Alright? With that, if I was to run this, you would see that that passed. Alright? And it would show that I had run 4 different tests. But there's another way. Let's look at subtraction. Subtraction, I decided to just do them as 2 different methods. So I have test sub 1 and test sub 2. Alright, so with test sub 1, alright, we have an int64 as a result, and we have tCalculator sub 10, 5. And this one's very similar, but the reason I did it this way is notice how I've hard-coded with a constant value 5 here, the expected value. Well, 5, the compiler doesn't know if that's an integer, an int64, etc. So because I have not supplied both parameters typed, I could just typecast 5 to an int64, but I chose not to. I can pass in the generic method here that allows us to specify how we're doing the comparison. R equals comes up with lots of different overloads. So we have string and boolean, integers, t-class, extended doubles, a double with a tolerance, with the extended, so that we can deal with errors where we're within a floating point tolerance. The same thing that we have here is subtraction 2. It's basically the same thing. We just tested it with a different set of values. Then I want to come down and let's look at multiply. Multiply we chose to do yet a different way, and that is it was put into the public section. Putting a method in the public section automatically makes it testable. So if I come in here and look, it's following the same pattern. We have the variable int64 test results, tCalculator.multiply 5, 5, assert are equal, and then obviously we have to tell it that type. So this is basically the same pattern that we've seen with the add, subtract, and multiply. But division becomes a little different. Division, we have exceptional behavior. Alright, so let's start with test 1. Alright, I have 25 divided by 5. And I can say, are they equal? And because this will map to an extended, there's an overload for it. If I just put 5.0, I can get the compiler to recognize that it's extended, and it'll work. The next one of our tests was this test 2, which is 3 divided by 2, so I expect 1.5. And then I want to point out something that's a little different in the assert, and it's important because exceptional behavior happens in a lot of code, and you want to test to make sure that when I pass those things in, that I get the exceptions that I'm expecting, or I don't get exceptions that I'm expecting. So the assert.willRaise takes an anonymous method here where you actually call, and in this case we're just going to call 10 divided by 0. No need to set a test result because we're going to ignore the result anyway, and say that, hey, we expect the E0 divide error. So if I run this right now, I'm going to see that 8 of these tests passed, but 2 failed. And you're going to see that I expected 1.5, but I got 1. And I expected an E div by 0 error, but was expecting an E0 divide error. With that, I can put a breakpoint on the given test that I now have failed, I could run it, and now I can step into my code. As I step into the code, it's pretty obvious to me right here, but number one, div num2, well, that's integer divide, and I'm expecting extended values. So what I really need to have here is, let's just change this to an actual division. So no longer is there a bug. And if I run this again, I now pass, and it actually passed both tests because of the class that was expecting in there. So if we go right back to the PowerPoint here, and the DUnitX assert class has over 70 overloads. So there's ones that we showed were pass and fail. We also showed are equal, but we didn't show are not equal. There's one called contains, and then one that says does not contain, is true, is false, is null or is not null, is empty and is not empty. And then it has some string ones such as contain, starts with, end with, raise or will not raise. It also has type checking. Like I said, there's 70 overloads. I can't get them all covered, obviously, in the time that we have here. But assert is a class that you want to go spend some time with in the code to figure out what's there. Another thing is, now that we've kind of given you an overview of DUnitX, you're going to have questions, and there are lots of places you can ask these questions, and I want to point them out. The first one is the Embarcadero community site. But we also have the actual, we have a Google Plus community that's been set up here, and that Google Plus community is a place where all of the developers that actually work on DUnitX are. And since DUnitX is an open source project, you can also go to the GitHub site. There's an issue tracker there, so if you do happen to find a bug, it is possible. Obviously, there are bugs in software, but DUnitX is very stable. And if you run into a problem, feel free to submit an issue there. And we also accept pull requests for with both feature enhancements, improvements to the project, as well as fixes to the bugs that you very much find. Another thing is the project wiki that is here. The project wiki contains some more documentation on how to use the project, because obviously I had to fly through things here in a much faster way than you might get when you're sitting down and typing it all. Next week on the skill sprints, we're going to be talking about understanding user behavior with app analytics, and so that'll be next Tuesday. Obviously there's 3 sessions like there always have been, and we look forward to seeing you at that one. We're going to now just open the time up to question and answers, and we'll see where we can go from there. Thanks.
What about complex situations where any answer is not known at the time of programming but will be computed by use of iterations and the like? Do you have any advice, Robert, for that kind of application?
Unit testing really requires knowing what you're going to be testing. So you have to have a known set of inputs and a known set of outputs. If for some reason there is some type of variable in that equation that you can't control, such as the date time, it's not going to work well for you. So you need to be able to inject those specific values as your inputs in the fixed unit test, so that you will always get the known set of outputs.
Yeah, so if you think about data that might be coming in because users are putting in forms, whatever, you could provide an interface in your unit tests for sample sets of data, right?
Yes, and so you can, obviously you need to have, the incoming data can be what you would expect from your user. I tend to like to say that you like to test the extremes, so you have both, the low ends and the high ends, because that's where your errors tend to occur. Numeric values, strings, etc. We have unit tests that test containers or collections, and those tests are that we have. There's some assert methods that say, hey, does it contain or doesn't contain, but those are all known sets of input, and I can test the extremes as how much I'm going to have in those as well. So just some thoughts on there.
Yep. Frank is asking, why should I use DUnitX? The normal unit test has a nice GUI, and for me, check routines are better to use. What's the benefit of DUnitX versus DUnit?
It's a preference. DUnitX does support MacOSX, and we're looking at supporting the mobile platforms. So where DUnit does not have that kind of support. Another thing that DUnitX does support is the Test Insight a tool. If you haven't seen that, it's incredible. It's an IDE plugin that allows you to view the tests within the IDE. So you really don't need a separate GUI runner. You just use your IDE. And so that is the GUI that DUnitX uses. But on the other hand, DUnit also supports the Test Insight plugin as well. So it is still a matter of preference.
Yep. Okay. And here's I'm going to add to the terse answer. I was typing the link to the bitbucket.org that Stefan Glinke has for his Test Insight plugin. So Gordon's asking, is Test Insight the GUI to show the unit test results? And go ahead, Robert.
Yeah, it is. We debated for a long time, and lots of people started and attempted different GUI runners. We've tried them both in FireMonkey. We've tried them both in VCL. But one of the things that we have when we're dealing with cross-platform testing environment is that your runner needs to be segregated from your actual tests. And the reason, unless it's a console, and the reason being is there are different constraints required in a FireMonkey application than a VCL, and I can't mix them together. But Test Insight solves that problem because it communicates via sockets with the IDE. And so that your tests are communicating to Test Insight on the machine, and it's just kind of beautiful the way it works. So it is something, it's a free tool that's available, so it's something that I would recommend.
Yeah, and I've got that up on the screen, but the link is in the Q&A log there. So let's go back. Okay. Maybe, Marco, this is a question for you. I'm not sure. Phyllis's question about, is DUnit scheduled for removal from C++ Builder at some point?
Not at this time. We plan keeping the runtime support because there are lots of developers who invested in building unit tests with DUnit. So we're not going to remove it in the short term. We have preference toward the DUnitX for the fact it's a newer framework, it's fully supported. The unit was a little bit abandoned, although there's been some new development happening recently. Overall, the fact that the DUnitX has more options, I mean, it's more flexibility in terms of cross-platform, is certainly good. And the other thing that it's nice to have a GUI runner as a single developer building a project. I mean, if it's a small, medium-sized project, but for a large application, you really don't want to use that model. You really want to have a build machine and then run a test, and then just have a way to capture the results in some format or automatically process the results. So that's where the real power of the DUnitX comes, in my point, is really when you're going towards continuous integration, towards automatic builds and testing scenarios, where the GUI runner is not the important piece of the equation.
Excellent. If you have any other questions, you can put them in the Q&A log. We've got just another couple minutes here, depending on which clock or watch you're looking at. Let's see, Phyllis is going, thanks for the DUnit lifetime info. I guess I should begin migrating DUnit test to DUnitX over the next year. Okay, Phyllis, thanks.
To go to that, though, there is a unit specifically for that makes that very easy.
For migrating?
For migrating. So basically it is a DUnit that provides test case that you can descend from, that has the check methods that people are used to in DUnit. It doesn't have everything, but has enough to get you migrating.
Is that also on the DUnitX site?
It's in the product. It's right.
Okay.
So yeah.
Excellent. Okay. Alpha's asking, how about testing how objects are behaving? Is there some units that invalidate them, making values unusable, or like how to test that? I'm not sure what he means by invalidating, or I guess deleting an object instance from memory and see what happens, or do you see that question? I'm not sure how.
Yeah, I see the question. I'm not sure the impact. One thing that I
guess he's saying deleting an object.
One thing that I thought that I didn't cover that I think should be pointed out, that is if your code by chance raises an exception that you're not expecting, it will fail the test and it will give you that exception result. So you don't have to trap for the unknown exceptions. You just have to look for the ones when you're expecting them, and so that was the only thing I demoed.
So again, trying to use an object that's gone would raise an exception. So
that's right.
Yep. Let's see. Ian made a comment that Test Insight is not available for XE8 yet, and I posted a note in reply that Stefan Glinke has posted a note. I typed noted, on the Test Insight site that he's making good progress and he's getting very close to having the complete XE8 integration for Test Insight. So stay tuned to the Test Insight project page and the notes, so that you can keep track of what's going on. Let's see, tip, attribute params can include types, test case. Let's see, check red, yep. Good point, Ian, thanks for the tip. So for example, a CL red and so on. If you have other comments or questions or tips and tricks, that's really cool. And as Robert mentioned, all of this is DUnitX is open source, so you can go and take a look at what they're doing up there and work that's going on, and that their goal is to have DUnitX supporting more than just Windows and OS 10, but also supporting mobile platforms and other things as we move forward. And DUnitX is included in the install, as well as DUnit is still supported, and there's no current plans to get rid of DUnitX for DUnit for now. So if you're using DUnit, especially for C++ projects, for example, it is still around and you can use it. Well, okay. Thank you all for joining us on this skill sprint. Next Tuesday is App Analytics, which is really cool. You can use it in your apps, both for VCL and FireMonkey. And we have different levels of capturing the events and giving you reports on the analytics that you would use in your applications that your users are using. It's 10,000 events. You can generate more, but we'll let you see the first 10,000 events per month for free, and then it goes from there. So stay tuned next Tuesday for that skill sprint. Otherwise, thank you all for showing up and being a part of the skill sprints, and we'll see you again next Tuesday.